this is the assignment for the project 4.2, the physics assignment. So as you can see, we have the exploding barrel in the middle, and we have spears surrounding them all. And they all go in their separate directions based on how far away they are from the actual explosion. Okay. If we go inside the exploder here, we can start with our linear function. From our get vector from source is simply just getting the direction from our actual explosion. So it gets the source location, then the target location. Target would be the spears, and our source would actually be the exploding barrel. It subtracts those and it returns the vector. And then if we get distance force by distance, we get the owner and it inputs our target. So it gets the owner and then it gets the distance from our target and our source. And then it divides that by our explosion radius to get a percent, and then it subtracts that from our 1 right here, which would be like 100%, 0 would be 0%. This basically would be how far it actually is from the source. And then it would multiply that by explosion force to get how much the explosion force will actually be on it. Alright, so if we head into our explode here, and then we start again, we simply get our spawn explosion particles and sound right here. It just gets the owners, then the actor transform spawns at that actor transform. We're using the stock explosion blueprint from our starter content inside of a 3D template. Right here, we get all static actors inside of explosion radius from the actor component. So basically, we just get the owner, we get the actor location, and then that'll be where our spear overlap actors start. It just creates a spear radius around our actual target of this with our target location, and then all the actors inside of that we're going to put inside of our array right here, the actors is pushed. And we get that location that the spear will actually be around at our spear location from right here, the actor location, and then we use our explosion radius. Alright, yeah, it will be how big the actual spear is. And then we have our for each loop where everything is out there array. We get each component by their class, by the static mesh component, and then we set the physics to simulate. And then we use our functions from before where we get the vector. It returns our vector, and we're using the owner here. We normalize that vector, and then we multiply that vector by our actual force that we're putting on it based on the distance. And then that'll be our actual impulse here. And then we come up right here, we get the owner again, owner of the component, which is the exploding barrel. And then we get that actor location, and that would be where the actual impulse starts. Okay. And then if we look at our Unreal nodes here, we start right here with basically the gameplay. I have it on the delay. Delay simply just makes it so that it delays whatever comes next by however long you want, the duration right here. And then we have our sequence for our flow control right here, which basically goes in order by each one, doing them in order. So from here, I just have them in 0. It starts with string 1, and then string 2, then string 3. And then in our thin 4, it continues to do a flip-flop. A flip-flop does either the A or the B. And then each one of these are also on a delay, so it's a little space between them so you can see the difference. And then we have them both on another flow control on our do once, which does them once, but they can't be reset. And this just simply plays one times message A and then one time message B. And then if we start it up, in the corner after 2 seconds, you can see it says string 2, string 3, and then it does the flip-flop after another 2 seconds. Alright, that's basically all for the physics project 4.2.